Hello, everyone. Thank you so much for being here. Before I start, can I just say how excited I am to finally be at a real conference again and see all of you people instead of cold Zoom windows. I think probably many of you share the sentiment, like it was about time. It makes me want to squeal with joy. But I won't do that because I have a very high-pitched voice and it would probably break some glass. Instead, I will talk about how to write code for humans. So I assume most of you are developers and write code on a daily basis. And you're probably thinking, what do you mean, writing code for humans? Code is for machines, right? Wrong. No. Code is written by humans, it's read by humans, and it's called as an API by humans. Humans are the primary consumers of code. So its user experience matters, its usability matters, its UI matters. So at this point, I expect many of you are like, what? UX? Usability? UI? What are we now, designers? However, in essence, these terms are not actually specific to graphical user interfaces that we've learned to associate them with. Let's take a look at some actual definitions. So user experience is defined as that user experience refers to a person's total experience using a particular product, system, or service. Nothing specific to graphical interfaces there. Usability is the ease of use and learnability of a human-made object. A human-made object, it's not even specific to computers. And the user interface is everything designed into an information device with which a human being may interact. An information device. Again, not even related to computers at all. So while many of you think of UIs as something like this, and this is actually two UIs, there's the Chrome interface around the spreadsheet, and there's also the Google Sheets interface inside the browser window. However, this is also a UI. Slides are a UI. My slides right now are a UI. I'm communicating with you. It's an information device. And in fact, these definitions could actually be broadened even more. If I say that these rain boots have poor usability, you all know what I'm talking about. And it has nothing to do with information or technology at all. Similarly, I took this photo of this tap at a restaurant bathroom in New York. So here's a small quiz. Let's suppose you went to this bathroom and wanted to wash your hands. What would you do? Who wants to take a guess at how this tap works? Yes? Okay, how many of you, though, thought that you had to lift the lever? About half of you. How many of you thought you had to turn the lever? About the other half. And yes, indeed, you were correct. You had to put your hands under it. But when you look at the tap, there is an affordance there that tells you either turn me or lift me. And whoever designed this knew that it was a bad design. And this is why they put documentation there. So all of these concepts apply to the entire world around us. They're not specific to GUIs and they're not even specific to computers. In fact, in the field of human-computer interaction, this book is the Bible. This is the book we recommend to all our students at MIT when they come to learn anything about usability. Any class at MIT that teaches usability recommends this as the textbook. And this book has nothing to do with graphical interfaces or even computers at all. It's about how everyday things are designed, like ovens, taps, elevators, elevator panels, all of these things. Because the same concepts apply every time we interact with any device. So where am I getting with this? Your code is also a UI. Every time you type a method, every time you design a class, every time you design a function, you are creating an interface that is going to be used by other humans. So the same principles apply. Remember, the I in API stands for interface. For this very reason. And I know that some of you might be thinking, okay, yeah, but for a tab, you can't really have documentation. Or even for a GUI, people don't look at help for Google Sheets, for example. But for code, everybody looks at documentation. So surely that's fine. I can just put all the complexity in documentation. Well, yes and no. You can rely on documentation a little more than with other things, than with GUIs, than with everyday objects. Yes, people will look at some documentation before using your API. But think about when you start using an API for the first time. And this kind of thinking in general is very useful for designing interfaces and APIs. Like, try to put yourself in the mind of the user a bit and empathize. So think back to when you use an API for the first time. Do you actually go to the docs and exhaustively read everything, memorizing every single exception, every single, all the syntax, every optional argument, like everything? No, you don't. You skim through the docs as quickly as you can, and then you jump straight to writing code, right? This is what your users are going to do as well. This is what everybody using your APIs does as well. They do not treat your documentation like a Bible that needs to be read from like top to bottom. They just read the absolute minimum and then start writing code. And your API needs to be designed to make this easy. So I've had an excellent introduction already, but a few words about where I'm coming from with this. So this topic is very close to my heart for a number of different reasons. So my day job is at MIT. I do research and sometimes I teach. My research is exactly about this topic, making programming easier, especially web programming. And I do teach some semesters. In fact, I was teaching this class when COVID hit, and we went remote halfway through. It was awful. I'm in the CSS working group since 2012, so I've been designing APIs for CSS. And I know many of you are thinking of JavaScript and typical programming languages when you think of APIs. But actually, designing features for a language like HTML and CSS, these are also APIs. I've started a bunch of open source projects, a bunch. Some of them are used by millions of websites. Most of them are small. And I've reviewed a lot of pull requests over the years, probably thousands. And it always pains me when I review a pull request where somebody clearly has put in a lot of time implementing some functionality, but put very little time into thinking how to expose this functionality to users. And sometimes this is not really fixable. Sometimes you can't iterate on a pull request like this. Sometimes it just ends up being closed because it's not just functionality that matters. Functionality that you can't actually use is pointless. And as of this year, as of the beginning of this year, I'm now reviewing APIs for the web as an elected member of the W3C TAG. How many of you know what the tag is? OK, very few, but don't worry. I do have some slides about how the sausage is made. So the W3C TAG is a special working group within W3C, the World Wide Web Consortium, whose goal is to ensure that new web technologies are well-designed, consistent with the rest of the web platform, and are not harmful to web users. TAG members are elected. Most of them are elected by the W3C members, which are big companies like Google, Microsoft, whatever. Some of them are appointed by the director, Tim Berners-Lee. And it's a very, very small group. It's only 11 members, and it's always 11 members when a seat frees up and someone gets elected. So what does the tag actually do on a day-to-day basis? A lot of our work is design reviews of new specifications. Chrome has tag review as part of its process, so they cannot implement a new web technology if it hasn't passed tag review. So every time they want to implement some new proposal, even if it comes from within Google, they have to come to the tag and say, hey, could you review this? Is it OK? Is it consistent? And also, a W3C spec cannot progress alongside the recommendation track without tag review. And many other companies have also tag review as part of their process. So from these design reviews, we distill our experience into design principles ethical web principles and findings. And while these design principles are primarily geared to people designing APIs for the web platform, I think they're actually very useful for developers writing JavaScript APIs as well, or designing HTML web components, or even defining variables in CSS. Every time you even define variables in CSS, you're still creating an API of sorts. So without further ado, the rest of the talk is going to be some advice about how to design a good API. Even though it's presented as commandments, they're more like rules of thumb. There's always exceptions. When you design UIs, when you design APIs, everything's a rule of thumb, and you should always exercise good judgment. So the very, very first thing is user needs. Do not just think, what functionality do I have to expose? That is the wrong way to start. You should start from the actual use cases. What do people want to do with this API? What problems are they trying to solve? Let's look at an example where this went wrong. So, how many of you remember this? I guess you're too young. So, this is one of the methods in the older DOM API. It's still supported by every browser. It's in browsers for like 20 years. And the way it works is it returns, compare document position, returns a bit mask about all the information you might possibly want to know about how element A is related to element B. Is it before it? Is it after it? Is it contained by it? Does it contain it? And then, if you've gone to actually extract real information from it, you have to do a bitwise AND with one of the constants. There's like about 8 constants. And so if you want to find whether element A contains element B, you have to do something like this. And of course, then you have to cast to a Boolean, because the result is a number. It's not an actual Boolean. And this is because somebody, I mean, I wasn't around when this was designed. It was before my time. But I'm willing to bet money that someone was thinking, let's expose all this functionality, and then people can do anything they want. They can check element A with element B in any way they might possibly want to. However, in practice, what people actually wanted was to check if A contains B, and they ended up having to do this thing. Much later, after libraries came along, after jQuery came along and became super popular, then some of its ideas started feeding back into the actual specifications, the actual web technologies, and we got much nicer syntax like this. And in general, the DOM API is rife of examples that could have been designed better and were eventually designed better. We're going to see a lot of them throughout this talk. This tells you exactly what it is. It solves the use case, the primary use case. It doesn't do everything, but it does the 80% at least of what users want to do, and it does it much better. So one takeaway is to start with use cases, start with example code. Like, before you start implementing an API, write out the use cases, not necessarily like actually write them down, but like in your head perhaps, and then write some example code of how would somebody use your API. Does it look nice? Does it read nicely? Does it read well? Does it make sense to someone that hasn't read any documentation? Does it require tedious boilerplate? If the question to any of those is a negative one, go back to the drawing board. Often with user-centered design, the API might actually end up being simpler than what you originally thought you needed, just like in this case. This is because a lot of complexity is often only included for completeness and not actually guided by any user needs. My next piece of advice, and this is a big one, is to make the simple easy and the complex possible. If you remember one thing from this talk, aside from use cases, that's very important too, is this. Make simple things easy and complex things possible. And as we'll see, there is some nuance about what simple really is. But as a general guideline, I think this is one of the most important ones. Let's look at an actual graphical interface. I assume most of you have used Google Calendar. When you want to add an event, there's a very quick window that lets you just quickly add an event, add some times, maybe adjust the duration by dragging. If you want to do anything more complicated, there's always the More Options button. We are used to this principle being applied to the interfaces we use on a day-to-day basis. But in interfaces, we often forget about it. In APIs, we often forget about it. My favorite bad example of this is the SVG DOM. Not SVG itself, but the SVG DOM, the JavaScript API that lets you interact with SVG and manipulate it. So take a look at this simple line of SVG that creates a circle. And let's suppose we wanted to interact and manipulate some of it with JavaScript. So we would get a reference to the element first. Yeah, that's easy. And then we would try to read the CX, the horizontal center of it. And since we know how to use the HTML DOM, we would probably try something like this. What do you expect it to return? What would you expect this to return? 50, right? So did I. Nope. It's an SVG animated length. What? I don't have any animations there. It's just a circle. No, it's an SVG animated length. OK, I look at the object that was returned. I'm like, OK, it has a base val and a nim val property. OK, I'm not doing any animations here. I guess I need base val. So then I try again, circle.cx.baseval. What do you expect this to return? 50, right? Yeah, me too. No, it's an SVG length. It's another object with a unit, even though there's no unit, and a value in specified units, and the entire kitchen sink. Everything is in there. Everything you might possibly want is in there. So you have to type circle.cx.baseval.value. What do you expect this to return? 50. It does return 50. Finally, after 3 steps. The problem with this is not that it does a lot. It's that it puts all this in your face when you don't need it. It would have been nice to have a way to get all these things, but not as the primary API that you use to interact with SVG, as some sort of side thing, perhaps. And it gets even worse. If I actually try to set this, if I try to set circle.cx, it just ignores what I've done, because it's not an object. It's even worse if I actually try to manipulate instead of reading. So don't do this sort of thing. This is a prime example of making complex things possible, but simple things difficult. So there are 3 primary ways of making simple things easy and complex things possible. They're not the only ways, but there are 3 good guidelines: shortcuts, configurability, and polymorphism. So let's take an example of firing synthetic events on elements. There are event object constructors like keyboard event, mouse event that let you pass in a bunch of parameters, and then you can call dispatch event to send that, to actually fire that event on an element. And this is not a bad API. It's perfectly fine. But it can sometimes get a little bit verbose when all you want to do is just fake a click on an element, which is a very common case. So there's a shortcut for the common cases. Just button.click. The upside of shortcuts is that you can hone down your UX, optimize it perfectly for the very, very common cases. If there are some cases that stand out, if you see people doing the same things again and again with your API, you can provide a shortcut. The downside of shortcuts is that there's a UX cliff, as we say. Once you get slightly more complex, then you need to go the complex route. The shortcut doesn't help you anymore. For example, if instead of simulating a simple click, you want to simulate a right click. It's up to you whether this is an acceptable trade-off or not. It depends on how common each different use case is. Configurability is another very common way of making simple things easy and common things possible. Basically, having a lot of parameters with nice defaults that are progressively revealed as your use case becomes more complex. Like, if you want to just produce some JSON that is minified, you can just call JSON.stringify. If you want to do something crazy, like custom serialization or whatever, there is actually a way to do that. You can provide a custom function and serialize things however you want. And you can also customize formatting as well. You can provide a tab character, and then your output is formatted. And similarly, polymorphism is another way of making simple things easy and complex things possible, having multiple signatures for the same thing. The user only has to learn one method, just different ways of calling it. So replace all in JavaScript is one good example of this. Your most simple case is replacing a string with a string, and you can do that. Once your use case becomes a little bit more complex and you need a regex, you can actually provide a regex. And if you want to do something particularly custom, you can still do it. You can provide a function as the replacement. So the benefits of polymorphism and configurability, actually, is a much smoother ease of use and power curve, and a smaller API. So what do I mean by ease of use and power curve? What is that? So every API call lies somewhere in these two axes. The vertical axis is how easy the API call was to make, and the horizontal axis is how much power it gave you. Now let's look at a few examples. An API that is super easy to use but only allows you to do basic things is suboptimal. An API that gives you a lot of power but is very complicated is also suboptimal. Remember, make simple things easy and complex things possible. Ideally, you want a curve where basic use cases start easy, and as they become more complex, you can trade off some of that ease for power. This orange curve is not ideal either, because note how fast it goes down, how fast ease of use drops. And then you get a progressively more expressive power, but at a very low usability. Ideally, you want something that drops much slower, not demanding a huge trade-off for slightly more complexity. Like, this would be ideal. Obviously, I don't expect you to start making graphs before you write code. It's just a framework about how to think. There is a very common Alan Kay quote that is often cited when this concept is brought up. Simple things should be simple, he said. Complex things should be possible. And this is about right. However, I would make one correction. It's common things that should be simple, not simple things necessarily. Often these are the same, but not always. Sometimes the common case is not actually simple at all. Let's take the sanitizer API as an example. This was recently brought to the tag for review. And it was actually designed quite well in that respect. The common case, when you want to sanitize HTML, untrusted input, like when you have a user-generated content that may contain HTML and you want to retain some HTML, but you also want it to be safe. You don't want it to have JavaScript in it. You want to prevent XSS. So today, most people use a library called DOM Purify for that, but there are efforts to standardize a new API called the Sanitizer API. And the common case there is actually not that simple to define. It's not just about dropping some elements and keeping others. It's also about dropping JavaScript URLs and that sort of thing. But that is what it does by default. If you just create a sanitizer object with no further configuration, that's what it does. If you want to do something custom and potentially less safe, you can also configure it. You can provide a list of elements to allow, a list of attributes to allow, and so on. So you can do complex things, and the common case is very easy, but the common case is not simple. So that is Leah's paraphrase of Alan Kay's maxim. Common things should be simple, complex things should be possible. In graphical interfaces, there is often a deadly sin called with unnecessary error conditions. What is unnecessary error conditions? There's a big misunderstanding there. So there is this quote that the best error message is the one that never shows up, which could be taken two ways. One is that errors should be silent, but that is not what he means. This is better understood with graphical interfaces, again, because we're used to dealing with them on a daily basis. You've all used sliders, right? So in a slider, when you want to, let's try and move this slider. So when you go all the way to the beginning, a slider just prevents you from moving further. There it is. A slider just prevents you from moving further. It doesn't show you an error message that the value is too small. It just doesn't let you move too much that way. Right? And similarly, if you want to increase the value, it just doesn't let you. It doesn't pop up an error message saying, value too large. How awful would that be? Instead, it constrains what you can do so that you always produce a valid value. Similarly, on many websites, when you select flights, for example, once you select a start date, your end date needs to be after it. It doesn't just pop up an error message that your end date is after your start date. That's bad UX. It just doesn't let you select an incorrect date. So how does this translate to APIs? Let's look at the DOM again. How many of you have used this remove child method at some point? Quite a lot. This is also one of the oldest DOM methods. It lets you remove an element from the DOM. But before you remove it, you have to also reference its parent. And if this div is not a child of the body element, you get an error. Fail to execute remove child on node. The node to be removed is not a child of this node. But why do I need to reference the node's parent to remove it? Am I asking it for permission? There is absolutely no reason to have a second reference there. And in fact, the newer remove method deals away with this. You just call remove on an element, and it just works. You don't need to actually ask its parent for permission. Similarly, there's also the insert before method. All of these were designed back at an era where they had a different philosophy about how to do these things, and you had to reference the parent for every manipulation. So again, if the reference node is not a child of the document element, again, you get an error. But there is no reason for that. And indeed, the new before method doesn't require this. So what's the takeaway here? You should always strive for a single source of truth. Do not require people to calculate things multiple times to get references that you can get. The implementation, if the implementation needs a reference to the parent, the implementation can get a reference to the parent. Inputs should be independent. Just like in graphical UIs. For example, credit card inputs. There is absolutely no reason to select your credit card type when you type your card number. It can just be detected. There is a lot of interfaces that require you to select this separately, but there is absolutely no reason for it. It's the same thing. If you can deduce some information that you need from the inputs, just figure it out in your code. Don't expect two inputs that are related. And indeed, like I said, the newer DOM API just requires two inputs, just the two inputs you need. What are you inserting, and which element are you inserting it before? Like I said, preventing error conditions is not the same as silent failure. A lot of people misunderstand this. Silent failure is bad. Silent failure is confusing. Let's look at the Canvas API. So I imagine most of you that write JavaScript have done something like this at some point, even if you haven't used the second parameter, because that's relatively new. So the Canvas API has a getContext method, and you can also provide some parameters. One of them that is supported today is alpha, but more are coming. And here's the catch. The first time getContext is called on a canvas, it creates the context based on those parameters. But any subsequent time that it's called, it returns the existing context, even when the parameters you've provided are different. So you get back a context that is exactly the same as what you got before, but you don't actually know that the parameters you provided have not been applied. I mean, there's a way to check. There's a getContextAttributes method. But if you don't think to check, it can really bite you. Because you used getContext, you provided some parameters. What you got back was not what you asked for. This is an example of silent failure. It should have really showed you an error that, like, these are either generated a new context object, which I believe that's difficult for implementation reasons, or just or it should just give you an error. Another common design principle is consistency. And I know you're probably thinking at this point, well, duh. Of course I'm going to design my API to be consistent. Like, everybody knows that. Yes, but there is more depth to it. So there are two kinds of consistency. There is internal consistency, which refers to consistency with other elements in a system. For example, in GUIs, internal consistency might be the consistency between different controls of an application or different applications within the same suite. And there is also external consistency that refers to consistency with other systems. For example, an application with other applications of that type. Whoa, what happened there? That was supposed to be text edit. I think I accidentally rotated it. Anyway, or even consistency between an application and the operating system. Like, how consistent is this UI with the rest of the world? So why does consistency matter? Because it helps learnability. It helps users transfer knowledge across different APIs. You will often see it being called the principle of least surprise as well. For example, again, the Canvas API, but now in the Hall of Fame. In the Canvas API, when you draw some text or when you use colors, this is exactly the same syntax as the CSS font property and the same colors as CSS color values. So it allows developers to transfer knowledge from CSS into Canvas. If there's an existing precedent, it's always good to look at existing precedent before you invent new things. However, it's not even as simple as two kinds of consistency. When designing APIs for the web, there's consistency within the API itself. There is consistency within the language. For example, JavaScript, if you're designing a JavaScript API, like, how consistent is your JavaScript API with the rest of the JavaScript language? You often see the APIs that, like, Python developers design, and they look exactly like Python. And it's like, no, this is not what you do in JavaScript, and vice versa. How consistent is it with the rest of the web platform, and also with any external precedent? For example, who remembers this awful thing? A few of you. I guess the others are blissfully too young. Lucky you. So this is some CSS syntax that Microsoft invented. Thankfully, it never became a standard. So before IE10, this was the only way to do gradients in CSS without images. And before IE9, it was the only way to do semi-transparent colors. So millions of web developers have written this. Millions of web developers have struggled with this syntax. Not only is the syntax incredibly verbose, but it sticks out like a sore thumb in the rest of your CSS. This does not look like CSS. This doesn't look like anything else in the web platform. Not only is it full of bizarre abbreviations, like prog-ed, dx, what? It includes a company name in it, but OK, let's move past that. But it's also not idiomatic to CSS at all. This is not what CSS syntax looks like. Where else in CSS do we have colons and dots in function names? Where else do we have equals signs to separate key and value pairs? At the time, we didn't even have 8-digit hex codes. Microsoft also invented those. And where else in CSS do we quote color values to use them? while this is comically bad, and I imagine nobody would try to do something like this today, we do get a lot of proposals for adding features to especially a CSS or HTML with syntax that is completely inconsistent with the rest of the language. So there are these different types of consistency that I mentioned that might often be at odds. Sometimes consistency within the API might be at odds with consistency with the language or consistency with the rest of the web platform and so on. And you need to pick which one to go with. Often, but not always, a good rule of thumb is to err on the side of the narrower internal consistency. Like, if you are designing a JavaScript API, chances are your users will primarily be JavaScript developers. So you should design to make things easier for them, and so on. Here is a recent example. We recently added lab colors to CSS, and there was a big debate in CSS, in the CSS working group, about the L parameter, the L coordinate. And the color science people were like, L needs to be a plain number. In all of color science, L is a plain number from 0 to 100. And a lot of the rest of the working group was like, no, it should be a percentage because lightnesses in CSS are percentages. And the second group won because we decided to go with consistency with the rest of the language than consistency with external precedent. Because most people that will use LAB colors in CSS are going to be people who write CSS, not color scientists. Sometimes it may make sense to break consistency when you think you can do much better. Here's an example of linear gradients in SVG. This is what they looked like. Specifying an angle was complicated. You have to use an actual transform function just to give your linear gradient an angle and make it diagonal. It's basically a gradient that looks like this up there. You have to specify exactly the position of the color stops, which means if you want to insert a color stop, you have to adjust all the other positions. And when Canvas added gradients, they largely went with this. They largely did a very similar thing and just ported it to JavaScript. And I can't fault them. I can't say this is an API Hall of Shame, because it is consistent. And there was one precedent in the web platform, and they went for that. But it does have the same similar problems. It's slightly better when specifying angles. You just do it with a line. But when we specified gradients in CSS, we were like, no, fuck that. We're not going to do any of this. Like, it needs to be much easier. So in CSS, when you specify gradients, you can provide keywords instead of having to calculate angles yourself and transforms and all of that. And you can just provide a series of color stops, and the browser just figures out what the position should be. And I think that was a win. I think that was a good thing. But it does break consistency with how gradients are specified elsewhere in the web platform. So sometimes it may make sense to break consistency, but think hard about it, weigh the pros and cons, like, is this a significant improvement? And if you're sure that it's a significant improvement, then it might be worth it. A good practice in UIs is also having sensible defaults. This is called the pending delete pattern. When you add a bookmark to Chrome, it pre-fills it with the title of the web page. And you can always type over it to specify something different. Also, an incredible example of sensible defaults is when you specify a Google form. And it actually uses machine learning to suggest answers. It's incredible how it works. So how does this translate to APIs? Let's look at an example. So there's the URL constructor. And you create URL objects by providing a URL. So if you try to provide a relative URL like this, you get a type error. Invalid URL. Why is it invalid? It's perfectly valid. I could use it anywhere else on the web platform. I could use it as a link href. I could use it as a script source or whatever. But no, it's not valid for creating URL objects. Because what it needs is an explicit base. Even though base will most likely be the location of the document, it still wants you to provide it. So you need to know that there's the second parameter, even if you don't actually need it, even if 80% of the uses are going to be just providing the location of the document. So sensible defaults allow API complexity to be progressively revealed. People don't need to know every little bit of your API to start using it. They can start using it by running simple API calls, and as they need more parameters, they can change these defaults to customize what it does. Sometimes not having defaults, sometimes there are valid reasons not to have defaults, because in the real world, usability is not the only consideration. It needs to be balanced against other things. So when you register a custom property with CSS, if you provide just a name and a syntax, you would expect that whether it inherits should be the default, like in the same way that when you use a custom property in your CSS, it inherits by default, so you would expect the same thing here. And if you provide that the syntax is a color, there are many obvious defaults here. It could be the initial value could be transparent, the initial value could be black. However, what the API actually does is that it complains that you didn't provide the inherits property. You didn't tell it whether it should inherit. And even if you do provide that, it complains, again, once more, because you didn't provide an initial value. There are actually valid reasons behind these. Like, we didn't want inherits true to be the default because it's more computationally intensive. So if we did the more usable thing, the API would be slower. So in practice, you often need to balance things. Sometimes other considerations can get in the way. One tip when you're using sensible defaults is to order parameters by frequency of use. A bad example here is the history API. There is, even though in most cases you want to provide null as the state and an empty string as the title, you still have to provide them both, because the actual URL, which is the parameter you always need to specify, is last. The parameter that you need to specify in practically 100% of use cases is last. It baffles me. And similarly, we saw earlier how JSON stringify allows you to nicely customize how the serialization happens. However, in many more cases, you need to specify that you want formatting. And unfortunately, you still have to provide null for the serialization function because the formatting parameter is last. Another big thing is argument traps, which are often called Boolean traps because the most common offender, the worst offender, is Boolean values. So there is this method to clone an element, and if you look at this call, it's like, what does this line do? Can anybody tell without looking at documentation what this does? I mean, surely it clones a node, but what does this true mean? Like, true, I really mean it? It actually means that I want to clone the entire subtree, but you wouldn't know by just looking at this code. And that is almost always true with Boolean arguments. There's no way to tell. Whereas if you had used a dictionary with a named parameter, it would make a lot more sense. You wouldn't need documentation to know that it's doing deep cloning. Add event listener used to have this problem with the last parameter. It would specify that you wanted to do capturing instead of bubbling, but you wouldn't know by just looking at it. However, more recently, it was redesigned to include a dictionary in the last parameter, where you can provide a named capture parameter and other ones as well. This is probably the worst offender, the old keyboard event initialization. Take a look. Take a moment to admire this beauty. It's so bad. It's so bad that it's good in a way. I don't think even the person that designed this API would actually be able to tell you today what all of these arguments do. Instead, the newer constructors are much more obvious, not to mention you can only provide the ones you actually need, not all of them. And sometimes, even when your arguments are not primitives, when they're the same type, you might have this problem. There's the old replace child method, and I always forget, is it new child that goes first or old child? New child or old child? I never remember. I have to look up documentation. Whereas the newer replace with method it's very obvious which one goes where. A lot of canvas drawing APIs, a lot of canvas drawing functions have this problem. It's like just a string of numbers. And what does this do? And there's a lot of tutorials that tell you, change these numbers to see what each of them is for. Can you imagine if we saw this in real life? Can you imagine buying a microwave or an oven and it had a label that says, press these buttons to see what each of them is for? Nobody does that. Or even in GUIs. Can you imagine opening a settings dialog and it has like 4 sliders? A parameter, some other parameter, a third parameter, the last parameter. And for definitions of these parameters, please see the manual. Or fiddle with them and see what they do. We don't do that anywhere else. Why is it acceptable in code? It would be much better to have a dictionary like this, or even like this. There are many different ways to do it. And you might say, yeah, but this is much more verbose. But remember, code is written once, but read many times. A very easy way to make these methods more readable is, as you saw, having an object literal argument in JavaScript. There are similar ways in other languages. There's another recent API that used this quite nicely. One of the last principles is the robustness principle. Be liberal in what you accept. In graphical interfaces, it often translates in, for example, credit card UIs. How many times, or telephones, how many times have you entered your credit card number or a phone number only to be told that it doesn't accept spaces or dashes? And it would have been so simple for the developer to just strip them away. But they didn't take the moment to do this. This is so common. Numbers only, no spaces or dashes. Why? This entry can only contain numbers. Why? There is no reason. You can just accept it all. Just take what I give you and figure it out. Or when an interface is very restrictive in terms of what states it accepts, like take a look at this error message. It's a beauty. You need to be logged in to log out. Please log in to log out. Sure, I'll do that. So I like the URL constructor, even though I don't like that it forces you to provide a second parameter if your URL is relative. I do like that it accepts a variety of inputs. You can provide a string. You can provide another URL object. It just clones it. You can even provide an object that looks like a URL object, like the location object. It's not actually a URL object. But because it has all the right properties, it's accepted just fine. So some ways to be liberal in terms of API design. We're not talking about politics here. Accept various types of objects, various different states. Accept both aggregate and singular operations. The last thing may need some explanation. So in GUIs, you can, for example, delete one email, or you can, in an email client, or you can select multiple and delete them at once. And similarly, there's a lot of APIs on the web that let you do one thing, but often you want to do multiple things. Like you want to set multiple attributes, and you have to loop, even though it would have been much simpler to accept an object literal on set attribute as well. Why not? Remember jQuery? That was one of the reasons it became so popular, because it accepted singular and aggregate arguments for everything. Some of the newer APIs take this into consideration. Like, there was the old append child, which only appended one element at a time. The newer append method accepts multiple, and you could even use an array with the spread operator. On the other hand, when you have with sets, there is an add method, but it only lets you add one thing at a time. And not only that, but if you try to add more, it doesn't complain. It doesn't tell you anything. It just only adds the first argument. And similarly, the set constructor accepts only iterables. If you try to provide anything that's not an iterable, you get an error. Why not just convert it to an iterable and add it to the set? It baffles me. Sometimes it may make sense to use different method names for singular and aggregate operations. That's fine. It does mean that people need to learn two different methods, but at least both are available. And lastly, and I do know I've went quite a bit over, but don't worry, lunch is waiting. I'm getting there. Very last thing, speak the user's language. We often see error messages that make absolutely no sense, such as this, and in the web platform, we also see this not just in error messages, but also names of things, like query selector all. Nobody thinks of this as querying. Querying makes us think of databases, not getting elements in a DOM. But by the time we realized this, it was way too late to change it. We actually tried to define a new method that was called find, but it was way too late at the time, and find clashed with some framework. So even though this would have been better, or even like find element or something, it's not how it happened. So when you're naming things, name things thoughtfully. Describe what it does, not how it works. Nobody cares about how it works. Similarly, add event listener. It's comically long. Literally every library that came out had much shorter names like these. Even add event. And probably the king of these, get bounding client rect. Why not just rect or bounding box or something like that? It's better to use few simple words whole. And some parting words, because API design is not just about following commandments. It's a way of thinking. And the way to think is to try and as you learn more about your subject, you lose the mindset you had in the beginning. In our industry, we prize being hardcore and knowing things, but actually, in usability, being able to remember how you thought when you were still a noob is very important. This is what gets you to design good APIs. Being able to say, I don't understand this. This doesn't make sense, which is something that many developers find hard to say because we're conditioned not to. And code with empathy. Try to put yourself in the mind of your user. Think, if I was using this API, how would I do this? Does it make sense? Can I write this code from memory, or do I need to look it up? Like, try to imagine that you're the user. Don't think, what do I need to expose? Think, how does using this feel like? That was it. Thank you very much.